to remove them from that area. So if you are lost in a US national park, you're probably going to be lost in the Grand Canyon National Park. And if you were to ask an individual expert, where might be a good area to search for a lost individual, given a certain number of parameters, like this might be the area that they give you. If you ask another expert, you might get a different estimate, so on and so forth. So once you've asked a large number of experts, the question then is, how are you going to properly integrate all this information? So how are you going to get a wisdom of crowds estimate from a task that requires spatial knowledge? So that's exactly what we wanted to do, and that's what we did in this experiment. So we have 50 participants per condition who are all current US residents. The stimuli were tile maps that use standard configurations found in data journalism, with the US states version on the left and the African countries version on the right. So when I talk about condition and I refer to like the US or to Africa, these are what I'm referring to. All 50 participants were presented with each target, either a state or a country, depending on which condition, once in each framing, present or absent in a randomized order. In the present framing, they were asked, where is Iowa located? Select as few states as possible, but be sure that Iowa is in the states that you select. And in the absent framing, where is Iowa not located? Select as many states as possible, but be sure Iowa is not in the states that you select. In both of these framings, participants were not allowed to view past responses, and they also received no feedback. And the survey was distributed on Prolific. So this is an example response for an individual in the present framing. They were asked, where is Iowa located? And they made the selection that's in blue. The labels have been added for our convenience, as is the black outline state, so that way we know actually where Iowa is located. So this is also a correct response that the individual provided. They correctly contained Iowa in their selection that they made. This is an example for that same individual, but in the absent framing. So they were asked, where is Iowa not located? And they made their selection in yellow. So this individual is also correct because Iowa is not in the selection that they gave for this response. So for the framing effects, we have two different ways that we're more or less asking the same question. And framing effects mean that a question is being asked in multiple ways, and that the ways that you're asking the question might influence the answer. So participants could respond either in a complementary manner, where there is no overlap or non-selected tiles, or in a non-complementary manner if there is a framing effect. So here's what a perfectly complementary response looks like. The individual selected, they were asked where is California located, and they made the selection in blue for present, and they made the selection in yellow for absent. And you can see that there's exactly, every state was either selected in the present or in the absent. There's no overlap, and there's no white in the map. This was an uncommon response, so this suggests that there was a framing effect, which we can see when we move to the other types of responses that we got. So this is an individual who has a response in both frames. This occurred just about as many times as the perfectly complementary responses. So you can see that when they were asked where California is located, they made a selection of 4 states in present, but they also have an overlap in the states that they selected when they were asked in absent. The most common response pattern was one where the individual left tiles unselected. So they have a small selection in present, they have a larger selection in absent, but they're not perfectly complementary. So there are some states that were left unselected. This occurred about 50% of the time in both the US and Africa. And then lastly, we have a non-complementary response pattern where there's some mix. They have some overlap and some tiles that they didn't select in either. So to summarize that, if we want to move forward and talk about things beyond just whether or not an individual provided a complementary or non-complementary response, we can look at the number of states or countries that they selected in the frames to look at how they manage the uncertainty of the task. So we're assuming that individuals that have a smaller number of selections, a less confident response is going to correspond to a higher number of selections, and a more confident response is going to correspond to a lower number of selections. So an individual who's pretty confident about where California is located would just select one state. An individual who isn't confident would make a really large selection. So now when I'm talking about the selections for present, we're looking at that area that they selected, and for absent, we're looking at the unselected area that they provided. So to look at the results for this, we have the US condition. We have it for present framing on the left, absent framing on the right. We have on the y-axis the number of times that they correctly contained the state, the target state in their selection, and then the selection size on the x-axis. So each of the different dots is an individual, and we can see that at least for the present, there's individuals are choosing 10 or fewer states when they make their selection size, but they're also only about 50% accurate on average. And on absent, we see that individuals have larger selection sizes that they're making, and they also have increased accuracy. So the two things to pay attention to are when we asked individuals to respond in an accurate manner, we asked them to provide a response that was sort of calibrated to their confidence. So if they were extremely confident and they were extremely accurate, their response would be in the top left corner. There's no one really there. And then if we asked them and they were really uncertain, they would provide a response that would be in the top right corner. So we can see that most individuals are providing an overconfident response in that they have a smaller selection size than they should have to have perfect accuracy for the task. And then also in the absent framing, an individual is providing a response with a larger selection size, but that's an effortful decision. So participants providing smaller selection sizes or the overconfident responses that we see is not just due to laziness. They're doing this intentionally and they're doing it effortfully. For the African framing, we see the same pattern that individuals make smaller selection sizes than should, so they're providing overconfident responses, and that the accuracy is higher in the absent framing than it is in the present, and also that they make larger selection sizes. So in summary, participants are overconfident in their selections, and this overconfidence can't be fully explained by laziness. So to then move to the wisdom of the crowds, we want to look at things at an aggregate level. The unweighted crowd response is a simple aggregation of participants' responses within each frame, but we could also have a different aggregation that weights the responses according to the number of states or countries they selected as a sort of proxy for confidence. So if we think about this one, an individual who made a selection of 10 states, each of those selections that they made gets a weight of 1/10. And then you would go through the usual steps of having the aggregate. So here's an example of an unweighted crowd response. We're now looking at on the aggregate level, and the color intensity corresponds to the number of individuals who selected that tile when they made their selections. So when they were asked where Rwanda is located, we can see that where Rwanda is actually located is outlined in black. So participants aren't the modal response or the most popular response in the darkest red color. That is not where Rwanda is located. But if you were to think about the top 6 most popular responses, that would include Rwanda as the correct location. And then now if we look at the weighted crowd response, this pattern is sort of drawn out even more. You can see that Rwanda is not the most popular response, but if we consider the top 6 or so responses, Rwanda would be in that weighted wisdom of crowd response. So we're interested in how the individual responses compare to that of the 2 aggregated crowd response. Is there a wisdom of crowd effect? So the crowd responses are going to denote how many states or countries are correctly included in the top K crowd selections, with the top K crowd selections referring to top 1 would be the modal response, top 2 would be the 2 most popular responses, and so on. So we have the same plots that I showed you earlier with the participants in blue, but now we've overlaid the weighted and the unweighted crowd aggregates. So the weighted and the unweighted might be difficult to tell apart, partly because they overlap almost entirely. The weighted is slightly better, but the unweighted also does really well. But one thing that we're interested in are there any participants who are outperforming these wisdom of crowd aggregates? And we do see that in present, there are 2 individuals, and then in absent, there are 3. So there are a few individuals that outperform the crowd, but in general, the wisdom of crowd aggregates is going to outperform them. And also, if you look at the x-axis, you see the selection size, which is referring to, for the wisdom of crowd estimates, how many states that you're considering. So are you considering the top most popular response, top 2, top 3, or so on? So once you get to the top 10 most popular responses, you're going to have an accuracy of about 100%. And then for Africa, we see similar patterns where the weighted crowd outperforms that of the unweighted crowd, but you don't see any individuals that are outperforming the crowd. So in both the US and in the African countries condition, we do see a wisdom of crowds effect because most of the participants aren't outperforming the aggregates. So we have the wisdom of crowd aggregate, which is looking at all individuals at the aggregate level, but we also have a wisdom of crowd within responses, which are made by combining the selections made in the present and absent frames. So if you just combine the responses within an individual, you'll get the wisdom of crowd within aggregate. And these responses can help us evaluate how participants treated 2 structurally identical tasks. So we have the US on the left, Africa on the right, and the points The tails are very faint, but there are tails on these plots that reference the points for the estimates the individual made in the present and the absent framings. And then the dots denote where the combined response pattern is. So if we think about it, we're now considering a larger selection that they made in both the present and the absent. So we would expect all the points to move to the right, but we also see movement up. So there's some improvement that's coming from considering a larger selection size as they move to the right, but because they're moving up, there's some additional information that we're getting from asking the question in two different ways. So the framing effect that we saw earlier, this is providing valuable information. So one of the things to think about is for the Wisdom crowds aggregate, do you actually need the full crowd? The aggregated crowd responses outperform 90% of the individuals, but do we need all of these participants for effective crowd performance? So we looked at a subset of size 2, 5, 10, and the full crowd of 50 to investigate this. So again, we have the US on the left, Africa on the right, and we see that as you increase the crowd size from 2 to 5 to 10 to 50, you see increased accuracy. But when you look at the US, once you've increased the crowd to about 10, you don't see as much improvement when you move to 50. So a crowd size of about 10 appears to be sufficient. And then in Africa, you see that the crowd increases and you see continual improvement as you move to the full crowd. So we definitely want to look at the full crowd over a full set for the African condition. But one of the things to think about here is you're asking US participants to evaluate where US states are located and then where African countries are located. So the US condition and the African countries tradition sort of serve as a knowledge manipulation. The US is going to be a high knowledge manipulation and the African country is going to be a low knowledge manipulation. So if you think about it that way, if you have a problem that you're asking individuals for information about and it's a high knowledge manipulation, you could probably get away with a smaller size depending on the difficulty of the task. But for the African countries condition where it's a low knowledge manipulation, you might want a full crowd of size 50 or maybe even more depending on the questions that you're asking them. So to summarize, we see evidence of a framing effect. Participants are overconfident in their responses. The aggregated crowd responses, especially the confidence weighted one, is superior to that of the individual participants. And to move forward with future work, we want to have a cognitive model that applies to this task. So cognitive modeling would provide us a way of understanding the knowledge representation and the decision processes that produced individual and collective behavior. And we want our cognitive model to consider an individual's expertise, their confidence in their selection, and the item's difficulty. So we have applied a similar model to a new data set where participants had a similar task where they identified where US cities were located, but they provided a radius of uncertainty. So it's a different measurement of uncertainty. And we have a model that applies to this. I'm happy to talk to you about that if you were interested, but I would like to thank the Bayesian Cognitive Modeling Lab at UCI and the Air Force Research Lab with special thanks to Jade King. Thank you very much.